Okay, good morning, guys. Let us start with the line acknowledgement to get things going. I saw some of those things in the chat. Give me a second. We acknowledge we're hosting the lands of Mississauga of the Anishinaabe and the Haudenosaunee Confederacy and the Wendat. We also recognizing the enduring presence of all First Nations, Métis, and Inuit people. Okay, so today is August 14th. Today is day 10. So we're getting towards the end of the course. Things go fast and furious. You guys would have handed in your unit test 3 already, which was due on Friday, but you guys had a little bit extra time on the weekend. So today your midterm marks are due, or your midterm marks are out. So before we get into that, because some people are saying, "Oh, I want to redo a test." Sorry, we're not redoing a test because we're going forward. Like, you gotta understand, we're going to unit 4 now, right? There's no time to go backwards. The only thing you can do is do well going forward. Okay, so we can't go backwards in summer school when it's this quick. It's not like day school where you have, days and days and days in between. We don't have days. We have like not many hours, really. Okay, so we have to move forward. Okay. Yeah, it's too late. Okay, it is too late. It's too late. Okay. The reason why it's too late, because I already marked it, so that means everyone has access to the people's answers now. Okay, if it's marked right or wrong, so it's too late. Okay. I did give people extra time if somehow they needed to submit it, the unit 3 test, but we're not going back to unit 2 and unit 1. It's too late. We're on unit 4 right now. Okay. You have to understand that that's how it is for summer school. It is what it is. There's no leeway as much as you have it during day school. Okay. Right now we're almost done unit 4. Unit 4 is going to be done tomorrow, and then there'll be a test coming up afterwards. So that's just how it works. Okay. Unfortunately. And the one thing you have to understand, there is plenty of marks on the table still. Okay. What does that mean, plenty of marks on the table? Well, we still have unit 4 test. We still have unit 5 evaluations to get done. Okay. We still have the 30% collimating, right? Where you guys are talking about a test, but the collimating is worth 30%. So I would be concerned about the future versus going backwards. Does that make sense? The collimating is worth 30%, and we're talking about a test that is like 3%, less than that maybe. Okay, so we need to go forward and think about doing better in the future. Okay, 30% is a lot of marks. So it's like, am I gonna go after 10 cents, or in the future I'm gonna get $1? Which one do I go for? I'm gonna go for the dollar. If I lost the 10 cents, that's fine. I'm gonna get $1 in the future if I do well. So that's what you gotta focus on, is the future. Okay. I've been saying that with this at the beginning of this course. Deadlines are deadlines. This is sort of like adulting. When you go to university, that's why you're taking functions. Deadlines are deadlines. Okay. So nothing changes. So your mark, if you're not passing, you can still pass the course. Okay. If you're, maybe you're 80 and you want to get 90, it's still possible to get 90. Okay. So that's all I can say about that. Okay. Someone's saying something about, okay, well, I'll double check that one, Mazur. Okay. Let's go forward and start what we're going to do today. So again, this is the quiz for today. We're talking about understanding angles. Identities and special triangles. That's what we're talking about today. Okay, so let's get into that. Let me actually view it as you guys. I always should do that just to make sure I see what you guys see. Okay, so let's go into content. Functions, trig, video lesson. We did that one. That was on Friday. Now we are doing lesson 2, which is understanding angles. Okay, so there's no video for this, so we're going to go through the PDF together, the lesson. We're understanding angles, and we're talking about terminal and related angles. So let's zoom in here. So in this section, we'll learn to identify different angles that have the same trigonometric ratio. Okay, same angles, and different angles, by the way, I meant to say different angles with the same trig ratio. And we know what the trig ratios, right? You know that the trig ratios are SOHCAHTOA, right? Sine, cosine, tangent. So you have different angles, but give you the same trig ratio, which means it'll give you the same, for example, we say sine is opposite over hypotenuse, right? And cosine is adjacent over hypotenuse. So to do this, you'll have to visualize the terminal arm rotating around a circle centered at the origin of a grid with the radius r. This is done so that we can extend the understanding of trig functions for a broader class of angles. Okay, so we're going to have to learn about a circle, which we're going to call it unit circle, and a terminal arm that goes around, that rotates around the circle, that gives you different angles when it crosses the circle. Okay, here we're looking at, this is it right here. Okay, so here is your circle, and we call this like a unit circle. Okay, you'll see this again in grade 12 if you take advanced functions. So here's your R is your terminal arm, and you can see R can rotate around the circle, and when it hits the circle, that point is considered X and Y. But then the arm, when it's in here, when it hits the circle, it gives you a 90-degree angle based on your X and Y. Okay, your point of intersection of the terminal arm with the circle is composed of X and Y coordinates. And then you see the angle that terminal arm makes with the X-axis. You can use that to give you the ratio, the trig ratio. So if I want to look at, say, I probably have to draw on the screen now. Come on. Okay. So this angle here, right, is basically considered as opposite. If you're looking at sine, it would be opposite over hypotenuse. And down here, X is your adjacent, okay? So now if you look at over here, sine theta is equal to, we know it's opposite over hypotenuse. And our hypotenuse is radius, and our opposite is y. Okay, that distance from here to here is y. That distance from here to here is x. So if you look at it again, x is your adjacent, if you're looking at it from the trig ratio, over hypotenuse. And then you know that y over x is your opposite over your adjacent. Okay, so that's how it's related. Now this terminal arm can move, right? So when we say we're dealing with, we want to find different angles, this terminal arm, right now it's over here. This terminal arm can be over here. And change the color. I'll do this color. This terminal arm could be over here. okay? And then it's gonna have its another X and Y points over there, okay? Now, again, it's if you were to look at the X and Y components, right? This is your X over here, this is your Y over here, and here you have a different data, okay? Now, again, you do the same thing, even though you're gonna have minus numbers here, right? Because you're gonna have a minus X over here. But it still works out if you want to find the sine of this angle, it's gonna be, and this is your R still, R doesn't change. It's still gonna be opposite over hypotenuse. Now the key is, if I know this angle here, then I know what this angle is over here, right? Because we know this whole line is 180. So if I figure out what this angle is over here using my trig ratio, then I know what this angle is over here, okay? So we use this in order to help us figure out angles within this circle, and depending on where the terminal arm hits. Okay, so let's scroll down, look at some more stuff. Here is important to know that we call this the cast rule, and basically what we're saying is everything in here is going to be all positive. When I figure out my angle, everything in here is going to be all positive. Okay. Okay. And what does that mean? Like if I were to draw my terminal arm here, and if I were to make a circle, okay, and everything in here, my X and my X and my Y, right? Everything here, whatever angle I make, is going to be positive. But that means because my X is positive, my Y is positive, that means all my trig ratios, okay, will all give me positive answers, okay? Because my X and Y are positive, right? Over here, on this side here, if I, draw a triangle there and I'm trying to get this angle, the only thing that's going to be positive here is going to be my sine. Why? Because sine is made up of Y over R, and Y is the hypotenuse. Sorry, Y is the opposite. And then over here, your X is negative. So if my X is negative, that means if I want to find my cos, I'm going to use a negative X over a positive R. So therefore, my angle, my trig ratio is going to be negative, right? That's what we're saying, the trig ratio, okay? Trig ratios are going to be positive. So this one's going to be, sine's going to be positive. The tan over here is going to be positive, and only the cosine here is going to be positive. And in this area here, all of them are positive. Okay, that's what we mean. And you can simply see, right, why all are positive, because it's your cos and your sine is made up of your Y and your X, Y over R. And if your if your X is in, like, R is always positive, but X and Y could be negative depending on which quadrant you're in, okay? And that's what makes the trig ratio positive or negative, depending on what your X and Y are, okay? So let's go down to the next. Somebody's trying to get in. Okay, so now we're gonna go down to here. So here's an example, right? So we look at the example, everything's written out there, you can see. Let me use a different color. I'll use this color. So you can see, if we're looking at given that sine theta, and sine is made up of Y over R, right? It's always made up of Y over R. So if we know the sine theta is 3 over 5, that means we know our y is 3 and we know our r is 5, right? We know that based on looking at that, right? So now it says, and that lies in the first quadrant. Determine exact values of cos. So we're going to try and find cos. Well, I can find cos because if I know, first of all, you can find cos because you can figure out what x is. X you can figure out because you can use Pythagoras theorem, right? Right? Because you know that r squared, using Pythagoras theorem, is going to equal to y squared plus x squared. And if I want to find x by itself, then I'm going to bring x over and get isolate x. So if I isolate x, it's going to be r squared minus minus y squared. Right? And that's how you find. So if I know r is 5, and if I know y is 3, I can figure out what x is. And that's what we did over here. Okay, so we know x is 4. That means we know that cos is made up of x over r. That means it's going to be 4 over 5. And then we can, for that, and then for the next one, we can find tan, right? Tan is made up of y over x. That means we know x is 3, sorry, x is 4, y is 3. So that's your tan ratio. Okay, so that's how you solve that. Okay. Let's go on to the next. Okay, so this one's a little bit tricky, but we're trying to find both angles for question 1 between 0 and 360. Okay, so question 1, we found they gave us sine theta is equal to 3 over 5. And now we're saying we want to find the angles, not just the trig ratio, we want to find the angles now between 0 and 360, okay? That have the same value of sine, same sine value. So we know, using the cast rule, that here is my cos area, that's my sine, my all of them. So we know here only the cos is going to be positive, and here all of the trig ratios are going to be positive. That means cos, sine, and tan. And over here only the sine is going to be positive. Okay, and over here only the tan is going to be positive. So if we know the angle here, because we can figure out the angle here, right? We can figure that angle because we know that the trig ratio is here. We know sine theta is equal to 3 over 5, and then we can isolate the angle to find the angle, and the angle works out to be 37. Okay, so sine 37 equals to 3 over 5. So we need to figure out where else I can get a positive sine 37. Well, the only other space I can get it is over here, right? And if I go like that, right, my y here is going to be positive, and my r is still positive. My x doesn't really matter because my x is it's a negative, but it's related to cos. So over here, I can get another sine. But what we're doing though is, you have to understand, you're not going to put another 37 here. You're going to put the difference between 180, because you're going in a clockwise. 180 minus 37 gives you 143. Okay, so technically, in this area here, my trig ratio of sine 37 also equals to sine 143. Okay, So sine 143 will also give me the same trig ratio of 3/5. Okay. And similarly, if you're looking at cosine, my bad, let me fix that. Looking at cosine, cosine's only positive in this quadrant, and you know it's positive here. So if I have 37 over here, I know I can put 37 over here, where that would be positive because my x is positive. But we're not looking at 37. We have to go from here to here to get what that angle is. So that angle is actually 360 minus 37. So that angle is 323. So therefore, we're saying that cos 37 gives you the same trig ratio as cos 323. Gives the same trig ratio, right? Because over here, I'll have my trig ratio here for cos would be x over r, and my x here is going to be positive, and my x is 4, and then even up here my x is 4, and my radius is still the same. So either way, they're still the same. So therefore, when I'm looking at this angle over here, it's going to give me the same trig ratio as this angle inside here. 37 gives you the same trig ratio as 323. Okay. So all this is being recorded, so I can erase this and go down to the next page. Same sort of thing. This question is asking similar questions. You're gonna get similar questions like this all day now. Find both angles between 0 and 360, where sine theta equals to negative. First of all, you want to figure out what that angle is. So how you figure out the angle? Just do inverse sine, and then you figure out the angle is negative 144, right? But we don't deal in negative angles, so we're dealing with a positive angle. So negative 144 is actually 316. Okay. So it's saying where do you get a negative? Where do you get a negative? Because it's a negative trig ratio. Where do you find negative sine trig ratio? The only place you can find a negative sine trig ratio is in this tan area and in this cos area. These are the areas we're going to find a negative sine. Okay. So if I'm trying to figure out, well, I already figured out this angle is 316. But now I want to figure out what the angle is over here. So we're still going to have the same trig ratio, but we're going to draw this trig ratio over here in the tan area, right? So we're going to say the same trig ratio. That means our x, sorry, not our x, our y is negative. Same thing over here. And here's our r, right? So this will give us a negative tan. But what's that angle? Well, this angle here has to be the same as this angle. So we're going to go from here to here. Well, that's basically 180 plus 44, right? To go from here to here. We have 180 and plus 44. Then that equals to 224 degrees, which is what we see right here. Okay, same thing. So it says find both angles. So we found one angle that gives you a negative sine theta, that gives you negative 0.7. So sine 316 gives you a negative 0.7. And then sine in this area, we said 225. So sine 224 degrees gives you, this is a negative by the way, a negative 0.7 trig ratio. Okay. That's how we get that. And I believe it's down there. Let me scroll down. If I scroll down, it's going to mess this up. So I'm going to have to clear that. Scroll down so you can see. Right? So sine 316 and equals the sine 225, and both equal to negative 0.27. Sorry, negative 0.7. That's what I meant to say. Okay, so now we're going to do this one again. This one here. Find both angles between 0 and 360 for tan theta equals to 2.7. Well, tan theta equals 2.7, right? So we know tan, this is a positive, by the way, it's a positive. That means positive is going to be in here, and it's also going to be in the tan area, okay? So now, first of all, let's find this angle. This angle will give us the angle over here. So this angle is 60, okay? That angle is 65, I meant to say. So if that angle is 65 in this area, so because we're going to look at it like this, right? Because you look at it like this, right? So now this is whatever your y over your x and your r. So if my tan, so my tan is basically y over x, I must have the same y over x over here. And when you think about it, even though this is a negative x and this is a negative y, well, if I have tan is based on y over x. But if I have a negative y and I have a negative x, it's the same thing, right? Negative gives you a positive, right? So over here is going to be my angle as well. So my angle I calculated is 65. Theta is equal to 65. But then I want to know what the angle is over here from here. So that's going to be 180 plus 65. So that's what we have here, 180 plus 65. So my angle from there to there is 245. So therefore, tan, that angle of 65 equals to the same trig ratio as tan of 245. And that trig ratio is 2.1. Okay? That's what you get there. I believe the answer is scroll down there. There you go. Okay? And now we're going to go to the next one. Same sort of stuff. Okay, so the point, so now we're doing these points, right? And this is what you may get in the worksheet questions. The point -7 and 19 lies on a terminal arm. Find the angle to the terminal arm. So the terminal arm is right there. Okay, let me actually be able to draw this. So that's the point. So we want to find this angle here. Okay. But also too, it's saying, and then find the reference angle. So we're trying to find it. So this is the terminal arm. This is the reference angle. The reference angle is the angle between the terminal arm and X, the closest angle, right? And the terminal arm, sorry. So the terminal arm is this angle over here, counterclockwise. We also want to find the reference angle. The reference angle is the angle between the terminal arm and your x-axis. So this is the reference angle. And then over here, this is your reference angle, okay? So you have a reference angle here and you have a reference angle here. The reason why you have the same, you can go back to grade 7, you know, the angles in between are going to be the opposite angles are the same. You can do that. That was back in grade 7. But also too, we know that if this is 19, my y is 19, and my x is 7 over here, right? We know that once we calculate this angle, right? Once we calculate this angle, that angle is going to be over here, but also too, I want to make sure that we're saying this right. Find reference angle. Yeah. Okay. So this is going to be of x and y. X and y. This is actually negative. It should be negative. That's what's showing up there. Okay. When you calculate that, actually, this is negative over here. Okay. And if that's negative over here, just think about that. The same ratio, my y over here is negative and my x is positive, right? So the same ratio exists. When you think about it, the same ratio exists. Over here, I'll have a negative, if I'm looking at it from tan, I'm going to have a negative, my bad, I'm going to have a positive. Let me erase that. So if I'm looking at it from 10, I'm going to have y, so be 19 over negative 7, right? I'm just showing you how this ratio is a negative. But then over here, on this side here, I have also a ratio that's negative. I'm going to have a negative 19 over a positive 7. So you can see how it's still the same. Negative outcome is still the same. So that's why this angle and this angle are the same. That's just giving you the theory of saying, instead of just saying going back to grade 10, so they're going back to grade 7, that this angle is opposite to that angle. That's why, but this is why it's opposite. This is why they're the same. Okay, your trig ratios are the same either way. So that's how you get the answer of 70. And over here, so from there, this angle is 70. So from there to there is going to be 180 minus 70 will give you this. So this is going to be 120. But let me scroll down so we can see the answers. Okay, my bad, not 120. 180 minus 70 gives you 110. Okay, so that would be the angle from here to here. So that's the terminal arm angle. Okay, the reference angle we calculated as 70, which is this small angle inside there. Okay. This is just basically showing if I'm like standard wise, I go from here to here is 360, right? So from here to here, if I'm going to go and look at that, from here to here, it's 30. But if I want to go back around and come back to that same spot, it's going to be 360 plus 30. And if I want to go around that same spot again, like a couple of times and get back to that same spot, it's going to be 360 plus the 390, okay, and so on. Right, so find 3 coterminal, and basically we say coterminal, angles on the same line, on the same terminal arm, right? So this angle here, this is the terminal arm. Okay, let me back up because we're explaining this again. Let me, okay, move this out of the way so I can actually see what I'm doing. So this is my terminal arm, right? Here's my terminal arm, right? So The only angle right now you see on that terminal arm is 30. To get another angle on that same terminal arm, you have to go back, you have to go around 360. Okay, that'll give you 390. If you want to get another terminal arm on that same angle, I want to get another angle on that same terminal arm, you have to go around again. It's like you're going around to get to the same spot and around again to the same spot. That's how you get the same angle on the same terminal angle on the same arm. That makes sense what I'm saying. The same, basically we're saying co-terminal angles. That's what we're saying there. Okay, so let's look at this one over here. Co-terminal angles for 60. Well, here's my 60. If I go around it once, here's 60. If I go around it once, I'm going to have 360 plus, I'm going to have 60 plus 360, gives you 420. And if I go around again, right, that's going to give me 360 twice. It's just saying find 3, right? So 360 twice plus 60 gives you 780. And if I went the opposite direction, that means I'm going this way. I can even count that as say minus 300. Okay, because I'm going in this direction. But they're all the same angle. That's what we're saying. All these are the same angle because they're on the same terminal arm. On the same terminal arm, which is this arrow right here. Okay, so we're done with that. Let's go on to the next lesson. There are questions with that. Okay, make sure you do those questions. They'll help you understand it better. Hopefully you guys are doing it, right? It helps you understand. Gotta do practice questions. Here are trig identities. Okay, so let's get into the trig identities. Okay, so we're gonna get into trig identities. Let me zoom in if I can. Okay, trigonomic identities. Identity is an equation that is always true regardless of the value of the variables. It's always true. That's what identity is. Okay, so we got a couple of identities here, right? These are the fundamental trig identities. Okay, so fundamental. I'll start with the middle one, the quotient identity. Quotient identity, which is we're saying tan theta over cos theta equals to, sorry, sine theta over cos theta equals to tan theta. Okay, that's always true. Okay, and what else is always true is sine squared theta plus cos squared theta is equal to 1. And then what also is always true is reciprocal. This here, so we know this is 1 over sine and 1 over cos, 1 over tan. On this side, this is called cosecant. Okay, so CSC is called cosecant. Cosecant is equal to 1 over sine theta, basically inverse sine theta. And here is ES or SEC. SEC stands for secant. So secant theta is equal to 1 over cos theta. And then we have this COT, which is cotangent theta is equal to 1 over tan theta. Okay, so these are always true. Okay, just showing it again. And what we're doing now with these identities is we have to prove. We have to use them to prove one side is equal to the other side. Okay, here are more identities. Here you can see this is just squared. Here there wasn't squared, but you can see it doesn't matter if it's squared. That means inverse is still applies. Same thing over here. This is squared, still applies over here. That means if that's squared and that's squared, that means the tan is squared as well. Okay, And here just isolating the sine squared theta and cosine squared theta. Okay, so here is our first proof. You know, basically when you want to prove, because that's the whole point of doing these identities, use these identities to be able to prove an equation. Okay, you have to try to change everything to in the form of sine. See, try changing everything to sine or cosine. So if I'm looking at this side over here, because the one is already the one, I can't do nothing with the one. We're going to prove, the whole idea is going to prove left side equals the right side. Okay. So in order for me to prove that this left side, which is cos theta times tan theta over sine theta, is equal to 1, I'm looking at over here. Well, remember it said first thing is change everything to cosine theta. This tan theta, I can change to sine over cosine using the identity, right? So change it over into that. So now, as a result, I have things that can cancel. Cos theta is the numerator, can cancel out with this cos theta, which is the denominator. So now I'm left with sine over sine. Well, sine over sine is just like saying anything over anything is 1. Okay, now I've just proved it. Left side equal to right side. Okay. Another example. I have here tan squared theta plus 1 is equal to secant squared theta. Well, based on what I said at the beginning, you want to change everything in terms of cos and sine. Okay, so I'm gonna look at the left side. Well, let's look at the right side first. The secant squared. Don't like that. Want to change it in form. Make it look at it like a cos. So, well, the only thing I can do is make it inverse. So secant squared theta is equal to 1 over cos squared theta. That's all I can't do nothing else with that. So I'm done here. So let me look at the left side. Okay, well I have here tan squared theta plus 1. The tan squared theta, I can change that to sine squared theta over cos squared theta. I can do that. So now I have this plus 1. Well, like the only way for me to add these two together, I have to have a common denominator, right? So I have to set them. So this 1, if I multiply by cos squared theta, can become cos squared theta over cos squared theta. Now I can add the numerators, right? Because the denominators are the same. It's like fractions, right? The denominators are the same, which are cos squared theta. So I can add the numerators. So if I add the numerators, I'm going to have sine squared theta plus cos squared theta. Well, sine squared theta plus cos squared theta, that's equal to the trig identity is equal to 1, right? Go back up here. Sine squared theta plus cos squared theta is equal to 1. And that's how we got that. So now we have left side is equal to the right side. So that's all we're doing here, proving. Now you have this one here. You have cos, prove that cos squared x. And now we're using x for the angle. So you can sometimes you'll see questions like that. Instead of theta, you'll have x. It's just the angle trying to figure out. It's equal to this right side. Okay, so we're looking at the left side. This cos squared x is, you can use that trig identity, right? That we saw up here. Cos squared instead of theta, we say x is equal to 1 minus sine theta, but instead of sine theta, we'll say x. So that's what we did over here. Okay. And then, so it's squared, right? Then when I look at this right side, well, this 1 minus sine x times 1 plus sine x, that's like difference of squares, isn't it? That means I'm going to have 1 times 1, which is just the 1, and then 1 times plus sine x, and then 1 times sine minus sine x, that cancels out. But then I have here sine x negative times sine x positive gives me a negative sine x squared. Works out to the same. Left side equals the right side. That's all you're doing, just proving. Okay. Now we have this one over here. This left side is 1 minus cos squared theta, and right side is sine theta cos theta tan theta. Okay, so we're going to deal with the right side first because we want to get rid of all, we want to turn everything in terms of cos and sine. So that tan needs to change. So we look at tan, we're going to change that into sine theta over cos theta. Now let's see what we can cancel. We can cancel out the cos. So I'm left with sine times sine. Well, sine times sine is sine squared, right? So on my right side, sine squared. Okay. Now, my left side, we know using the trig ratio that 1 minus cos squared theta is equal to sine squared theta, right? We go back up here so I can show you Pythagoras identity for the trig ratio, right? So that's what we got. Okay. You can prove it without changing the left side, depending on what you have to do. But over here, you can see you have to show both sides equal to the same, right? So here I had to change my left side so it looks like the right side. Okay. Sometimes it maybe if it's already set like this, you can already just, you know, it's just a matter of you're talking about example 4. Okay, example 4. Well, let's look at example 4, right? There was no other way. I have to change it, right? If I just prove the right side, I'm just left with this. I got to change both sides, make them both show the same. Okay, my bad. So let's look at example 5. Example 5 is kind of weird. So you have sine to the power of 6 theta, and then on the right side you have this. Okay. So now, probably the only thing we can do is work on the right side because we really can't do nothing with this over here. Let's work on the right side. And the right side is kind of, let's look inside the brackets. Well, we know inside the bracket 1 minus cos squared theta is equal to sine squared theta. Okay, so now we have that. Simple now, right? Because now this exponent on the outside multiplies the exponents on the inside. So there you go, done. That's finished. Left side equals the right side. This is an example. We didn't even change the left side. Here's another example. Okay. Our right side is 1 plus cos x. Our left side is sine squared 1. So the only thing we can do is you probably can't really do much with the right side. So I would start with the left side and see what you can do. Well, 1 minus cos squared, right? First of all, look at the numerator. This can be changed to, right, using the Pythagoras identity. The sine squared x can equal to 1 minus cos squared x. Okay, so now I have that. But this here, we looked at 1 minus cos squared x can be looked at as difference of squares, right? So if I were to separate this into 2 brackets or factor it out in difference of squares, I have 1 plus cos x, and then I have 1 minus cos x. So now I can cancel out the 1 minus cos x. I'm just left with 1 plus cos x. So there you go. I have 1 plus cos x over here, and I have 1 plus cos x over here. And that is it. Okay. So now let's go. You really need to do these problem questions, okay? So that is it as far as the lessons. So you need to do these questions, okay? Get into the habit of doing these questions and making sure you got your answers. Right? If you look at it, and it's not for marks, always not for marks, right? Don't think they're for marks. You submit them and then, oh, wow, it's not the quiz. So here are the worksheets. Da-da-da. Okay. Oh, what am I looking at? This is the wrong one. Trig ratios. This is the wrong one. My bad. Oops, I'm going into the wrong one now. Go into content. For today, today's the 14th, right? So the one for the 14th is this one over here, understanding angles. So let me go into that. Let's go to that one. Yeah, understanding angles. Okay. So you click on that. Let's look at some of these questions here. So we talked about that. So, right. So there's a worksheet for each. Given the terminal arm, determine the exact primary values, right? So you're going to do that. And these are, when we talk about primary values, we're talking about sine, cos, and tan, okay? So what's the sine, cos, and tan for this? What's the sine, cos, and tan for that? What's the sine, cos, and tan for that, okay? And then let's go on to the next one. And here is the questions for today. And I guess, again, not for marks, but do them, please. Okay, and then you know there's a quiz for today, right? For all the stuff that you're doing. So this will help you for the quiz. Not to mention it'll help you for the, and here's proving, right? You got to prove. Okay, prove. And that's it, you're just proving, okay? And that is it for today. And then, you know, there's a quiz for today, August 14th. Looks like it's like you get 2 attempts, okay? The other thing I want you guys to do, let me go back to the home page. I need you guys to go through, fill this out before 1 o'clock, okay? This means fill it out because you looked at your mark, and if you saw a mark, confirm the mark and click on that. Again, this is just midterm. It's not final. Final, it can be adjustments. Midterm is just a snapshot of where you are today. It doesn't mean you're going to end that way. Okay, you can be riding on 55. Doesn't mean you're going to end at 55. This is a snapshot today. You can be riding at 100. Some people, maybe somebody's at 100% in this class. I think there's 2 people or maybe 1 at 100%. Doesn't mean you'll stay at 100%, but you're at 100%. Okay, so there's people doing well and some people are still struggling. But again, the key is to do the work and meet your deadlines. Okay, meet your deadlines because you don't want to get a 0 on something. Okay, we got to keep it moving. And that's why you got to make sure you. No, your unit 3 marks. It's the unit 3 test is not marked because some people just handed it in and it's not part of the midterm. So the unit 3, what's part of the midterm is your unit 2 and your unit 1 test and all the quizzes that you did up to unit 3. Okay, so that's what's on your midterm mark. So let me stop sharing my screen. Let me stop recording.